Yeah.
And remind me, are the grid fins, do they still fold in?
No.
No. Is that going to be permanently that way?
Yeah, so what I'm trying to have us all just implement rigorously is the sort of 5-step process. First, make your requirements less dumb. Your requirements are definitely dumb. It does not matter who gave them to you. It's particularly dangerous if a smart person gave you the requirements, because you might not question them enough.
Yeah, you might take it as like gospel. Like, yes. I have to do this thing.
Everyone's wrong, no matter who you are. Everyone's wrong some of the time. So make your requirements less dumb. Then try very hard to delete the part or process. This is actually very important. If you're not occasionally adding things back in, you are not deleting enough. Right. The bias tends to be very strongly towards, let's add this part or process step in case we need it. But you can basically make in-case arguments for so many things. And for a rocket that is trying to achieve, try to be the first fully reusable rocket, there's never been a fully reusable rocket. People don't understand. Like, this is like the holy grail of rocketry. 100%. Okay. And so you really need, you have to run at tight margins, because if you don't run tight margins, you're going to get nothing to orbit.
Right.
So you got to delete the part or process step, super important, and you can't like hedge your bets. That's why the grid fins, for example, do not fold down, because that's a whole extra mechanism that we don't need.
And then compensate for it by having strong enough engine authority to steer it in the lower atmosphere.
Actually, our simulations, so we don't really need any extra engine authority. As long as the grid fins, basically follow the flow, they're not really disturbing the flow. It's really neither here nor there.
So
as long as they don't have a high angle of attack, it doesn't matter.
A few degrees or something, or within a degree or two.
So, but in any case, it's a thing we could add later.
Right.
So now these grid fins are humongous. We'll go see them. But they're like, like a dinosaur bear trap. Okay, it's like a bit of bear trap or a dinosaur. That's what these things look like. And if you have a whole mechanism for folding them, that's like clearly a part that we don't need.
Yep.
So this was a good design decision that actually I didn't come up with, and it was like great. But it followed the principle of like delete the part, delete the process. And I was like, great, good idea. Let's not fold them. Why were we folding them anyway? Somewhere random, and also whatever requirement or constraint you have, it must come with a name, not a department, because you can't ask the department. You have to ask a person, and that person who's putting forward the requirement or constraint must agree that they must take responsibility for that requirement. Otherwise, you can have a requirement that basically an intern 2 years ago randomly came up with off the cuff, and they're not even at the company anymore.
Right.
But it came from the, let's say, aeroloads department. They're like, actually, no one in the aeroloads department actually currently agrees with that. This is by the way, happened several times.
So again, it can be literally.
I don't want to put it on the aeroloads department, but there's like, there's every department. So
it can be thought of as gospel again, but it might be something that's just totally in passing. Like or someone played too much Kerbal and had fins at the top of the rocket, and then it just did this.
These things are often just way more silly than you'd think. Anyway, so step 1, make your requirements less dumb. Step 2, delete the part or process step. If you're not deleting a part or process step at least 10% of the time, basically, if you're not adding things back in 10% of the time, you're clearly not deleting enough.
Right.
And then only the third step is simplify or optimize. The third step, not the first step. The reason it's the third step is because it's very common. It's possibly the most common error of a smart engineer is to optimize a thing that should not exist.
Right.
Okay.
Right.
And they say, well, why would people do that? Well, everyone's been trained in high school and college that you got to answer the questions, convergent logic.
Yep.
So you can't tell the professor your question is dumb, you'll get a bad grade. You have to answer the question.
Yep.
So everyone's basically, without knowing it, they got like mental straitjacket on. That is, they'll work on optimizing the thing that should simply not exist.
Right. Right.
And then finally, you get to step 4, which is accelerate cycle time. You're moving too slowly, go faster. but don't go faster until you have worked on the other three things first.
Gotcha.
Like if you're digging, you know, your grave, don't dig it faster. Stop digging your grave.
Right.
But you can always make things go faster. And then the final step is automate. Now I personally made the mistake of going backwards on all 5 steps, multiple times. So I have to repeat this. Yes, multiple times on Model 3, where literally I automated, accelerated, simplified, and then deleted. Like one example I've talked about before is like there were these like fiberglass mats on top of the Model 3 battery pack that were in between the floor pan and the battery. And it was at one point choking the battery pack production line, and I was like basically living on the battery pack production line, like trying to fix the line, because it was like choking the entire Model 3 production program. So, the first mistake was we should not have. I like try to fix the automation, like make the robot better, make it like the robot move faster, a shorter path, increase the torque, delete the reverse 720 degrees on the bolt, because that's unnecessary. Just go forward fast, not at 20% rate, at 100% rate. Instead of spackling glue on the entire battery pack, just put little dabs of glue, because the fiberglass mats are sandwiched between the battery pack and the floor pan anyway. So all you need is like something to hold them in place until you bolt the battery pack into the car.
Gotcha.
So automating was a mistake. Then accelerating was a mistake. Then optimizing was a mistake. And finally I said, what the hell are these mats for? And I asked the battery safety team, because I like, are these mats for, what are these mats for? They said, oh, these mats, I said, oh, they're for fire protection or something? They said, no, they're for noise and vibration. So you don't get that. And I said, but you're the battery department. Then I asked an NBA, a noise vibration harshness team, what's it for? They said fire safety. So literally, it was like being in a Dilbert cartoon, okay? It was like, actually, I feel like I'm in a Dilbert cartoon quite frequently. So I'm like, you know, like, are we in some simulation where I'm like trapped in some like Kafkaesque / Dilbert cartoon situation? But that's what it feels like a lot. So then finally, okay, great. Let's try a car with the fiberglass mats and without. And they put a microphone in both, and see if you can tell the difference. You cannot. You cannot tell. In fact, I was like, which one is which? So we just deleted them and just bypassed this $2 million robot cell. It was just a complete pile of nonsense. Another mistake that tends to happen in production is too much in-process testing. When you're first setting up a production line, you don't know where things are breaking. You don't know where things are breaking, so you'll test like work in process at various steps, and because you want to isolate where's the mistake occurring. So a very common issue with production lines is to have is to not remove the in-process testing after you've diagnosed where the problems are. So basically, if you have like a very high acceptance, if things are getting to end-of-line testing and are passing, then you don't need to do in-process testing. So, but what tends to happen is there'll be an initial like development engineering team that will be like basically debugging the production line, but then they will forget to take out the in-process testing steps. So then what happens is the in-process tester will often choke the cycle time, choke the line production time. It'll be like the limiter. It'll also have some number of false positives and false negatives. But I mean, it'll be like false positives, like then you're like rejecting good parts.
Right.
Really in volume production, if things are working well, you're really just taking a risk. Will this subsystem be rejected during the production process or at the end? And so you just really want to move things pretty much almost always to just test at the end of the line, and that's it. Maybe there's like one or two in-process steps that are hard to test at end of line, but basically remove almost everything.
So how heavy are these guys?
Man, these are. I started to think. Actually, I don't know the number offhand, but probably at least 3 tons. I'm guessing. It's eyeballing it.
And
But this is not. This is why, like, when I say it's like a moving target, this is not the. Like, I wouldn't take this to the bank. Like, it's not. You know, there's quite a lot of mass we can get out of this.
Right, right. 'Cause yours is just good enough for now. Like that's.
Yeah, it's good enough for now. I mean, I'm pretty sure we can cut the weight of that in half. Like that's, you know, we're not even really trying to optimize the gauge. That's just basically plate. You know, that's just like cut plate,
Right.
welded together. So we first just got to make the damn thing work, and then we'll optimize it.
Yeah, of course. Which again is something the Soviet Union was so good. That was like minimum viable product, basically. Get it good enough to fly and test. And obviously you guys did that with Starship big time with 8, 9, 10, 11, 15 was like, let's just get it out there, see what works, see what doesn't, and iterate, you know?
Yeah, and if you look at like the various reasons, like where we blew up starships, like, and you looked at the risk list, none of the reasons it blew up were on the risk list.
Really?
Yeah, there was like no. Maybe you could argue like one of them maybe was on somebody's risk list, but it wasn't brought up beforehand. Put it that way.
Right.
So